We're going to look at an optics question from Winter 2016, paper 52, and it's question 3. The number one thing to do in optics questions is to read the instructions carefully and follow them exactly. In this question, it tells you to draw a line at an angle of incidence of 20 degrees to the left of the normal. This is what that would look like. It specifies that the line should be 8 centimeters long. That means the line should be 8 centimeters long. Exactly. Make sure you label everything that you're told to label. I've followed all of the instructions in part A, and notice how my ray trace sheet looks exactly like the one in the diagram given to me. I added the label for C on later on. This involves now using the optics pins. Pin 1, P1, needs to be placed at point B. It tells you this in the instructions. That's the end of the 8 centimeter long line. Pin 2 should be pinned a suitable distance away from pin 1. A suitable distance means over 5 centimeters away from pin 1. This is true for most, if not all, optics questions. This question doesn't tell me to label pins 1 and 2, but I'm going to do it to make it explicitly clear to the examiner what I want them to mark and that I know exactly what I am doing. Now it tells me to look in the mirror from the direction of the eye shown. So I need to look in the mirror from the direction of the eye shown in the diagram. Look at the images in the mirror of the pins. At the moment, they are separated. If I move them, there's a point where they end up in a line. This is the point where I want to put my pins P3 and P4 also in line with them. The actual pins, not the images of P3 and P4, the actual pins in line with them as such. And again, a suitable distance means more than 5 centimeters apart. Can you see how the actual pins of P3 and P4 are now in a straight line with the images of P1 and P2 in the mirror? This is now what my ray trace sheet looks like. The instructions tell me to label P3 and P4, so I labelled P3 and P4. Now I need to remove the pins and join P3 and P4 up to point A. Now this question involves reflection, and I know the law of reflection. The angle of reflection is equal to the angle of incidence. So if my angle of incidence was 20 degrees, I should have an angle of reflection of 20 degrees. But if you notice in the video, optic pins are about 1 millimeter thick, and it's hard to get them perfectly vertical. So my angle is a few degrees out, but that's okay. Moving on to part C, it tells me to label the point where my line, my reflected ray, crosses the XY line I drew at the beginning. I need to label this as D, and then I need to measure distance CD. This is the distance CD. On my sheet here, it's 1.9 centimeters long. Now, I need to repeat the whole process for different angles of incidence that I'm told. For these angles, I don't need to label my pins, but I can if I want to. It's not a practical difficulty in obtaining accurate readings that I'm looking at the mirror from different angles. That's kind of the point of the experiment. I'm doing an experiment with reflection. If my angle of incidence is 60, my angle of reflection should be 60. And this is my final ray trace sheet. My reading of D should be from point C to my reflected ray of that angle each time. Now, I just need to carry on answering the questions and plot a graph.